Hello and welcome to our webinar discussion on unifying VMs and containers, the OpenShift Virtualization Advantage. My name is Ross Beard. I'm here with Shadowsoft, and I have Shadowsoft's Chief Architect, Derek Sutherland, here to join me on this discussion. Derek, can you introduce yourself for the audience?
Sure. Yeah. So thanks for the brief introduction. I'm Derek Sutherland. I've been here for about 10 years. I've been in the consulting industry for a little over that. I've been doing software development for about 15 years, and I've been using OpenShift since OpenShift 3 or OpenShift 2, excuse me, which is about 12 years ago, prior to the Kubernetes changeover and making everything more container native driven.
Yeah, one of my favorite stories is when I was doing a website refresh in 2023, I came across a blog post that you authored in 2013 on OpenShift.
Yeah.
Can you believe it? We were talking about OpenShift back in 2013.
I know it's really wild, honestly, to think that it's been going and growing for so long. But it's awesome that we just were lucky enough or blessed enough to make the right headbits into this technology set. So it's very 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 cool.
Yeah. So we're here today because, with the VMware Broadcom acquisition last year, there's been a lot of uncertainty with customers and their renewals going up 3 to 5x, uncertainty with the product and the support. So we're hearing from many companies that they're looking for alternatives. So let's kick things off and tell me about some of the key challenges with some of these traditional virtualization platforms.
Well, there's several things. Probably the big thing with the entire acquisition, obviously, is that because of the cost growth, we now have an opportunity to start looking at something differently because we know everybody else is, right? But in terms of traditional IT infrastructure that's based on something like VMware, you're looking at a solution that's kind of point specific to virtualization. Now, you do have a little bit of virtualized networking in terms of having your own VM networks that are inside the environment, which works great for certain things, but it's not full bore in terms of how you do things like DNS, how you do things like route tables from one area to another, how you manage the growth and scalability of different systems. You're a little bit more fundamentally limited, again, because it's kind of more of a traditional system. When you want to go provision a VM, that's all you're doing. You're not getting any of the other things you might need to run what I would say kind of a virtual data center, which would look like also, and there is some improvements in this area around virtual storage and whatnot, but when I try and think of what I need inside of a world like VMs, is it's a lot larger than just a virtual machine itself. It's networking, it's disaster recovery, it's storage, it's how we get things to be routable to one another. It's how we start developing on those workloads and getting access to them quickly. It's how we can get users to just be able to look at their particular thing and not see everything under the hood, to not overwhelm people. It's a whole lot.
So sounds very fragmented with respect to the provisioning process.
I would fragmented, disjointed, however you want to word it. The reality is, a lot of times when you're dealing with traditional VMware, now granted, you could use vSAN and have some extendable virtual storage and some virtual networking components, but at the end of the day, there's a lot more involved. If someone wants to go get more storage, if they want to get authorization for how two systems should be able to network, communicate with one another, all of these things usually have a ticketing process, and then someone manually go altering a different system. They might have to go manually alter an F5. They might have to go change, a bind server or an Active Directory server. They might have to go provision storage from like a NetApp storage array and then bind it to the virtualization layer. And then whoever's managing the virtualization team in platform itself, they got to go provision VMs on behalf of people. So all these different groups, it's all people that have different skill sets, and they all have their own unique individual processes that are, I would say, not tightly interwoven, because you're integrating different technology stacks that are from all different types of companies. So yes, it's a little bit fragmented or disjointed, and I would say that can be quite challenging in most organizations, where provisioning something could take days, weeks even, instead of maybe minutes or seconds, depending upon what you would actually want. Hey, I need this. Can I just have this? As long as someone, hits an approval checkbox, right?
Got it. So what's the new approach? What's the solution here?
Yeah, so the way that OpenShift has been designed, which OpenShift originally was a software-defined data center, and then it became a software-defined data center for containers. Now it's for containers and virtual machines, right? What that allows you to do ultimately is everything from network policy authoring, DNS, routing, service discovery, how you provision systems, all of these things are essentially automated for you and give you a simple syntax and API to be able to make a request for the different resources you need. OpenShift gets really tightly integrated into different storage providers using different storage provider plugins, different network providers. It doesn't matter if you're in the cloud, on premise, wherever. And then again, because we have this virtualization component to it now we can have containers and virtual machines side by side. So from a provisioning process, if someone says, hey, I need a VM and I need to talk to this database, and the database could be in a VM, it could be in a container, someone could have the entire automation inside of OpenShift for, okay, we're going to spin you out a VM. We're going to automatically authorize that VM to only talk to this database that's running in a container inside of here. And then we're going to have that information only available to you. We're keeping the rest of the OpenShift platform kind of abstracted and away from you. So you just get access to your UI for your virtual machine, and that's it. Which the benefit to that is you're ultimately just setting up approval chains for who has to authorize what's going to occur. And you can unify the way that you end up distributing and end up releasing these different typically fragmented or again disjointed systems.
Got it. So this is really what we've been doing with OpenShift for a number of years now with containerized applications. We're now saying, look, we can bring your VMs into this same new platform and process.
Yeah, and I think it's more than even just saying bringing them into the same new platform and process, but allowing those things to commingle with each other, right? Because that's the challenge that a lot of other providers are trying to solve. Like VMware with Tanzu, for example, it's trying to put Kubernetes on top of, VMware to try and make those things interplay, but it's not been built from the ground up for that. It's a much easier, narrative to say, hey, OpenShift, let's just sideload a VM. And that VM essentially is running in a Kubernetes pod inside of the same constructs as everything else. So it gets to use the same benefits of all the technology stacks that previously existed and be able to automatically communicate with those workloads without having to reinvent the wheel, so to speak.
Got it. So thinking about this modernization journey, what's your recommendation for customers that are faced with this challenge where they're now looking for a VMware or a virtualization alternative?
Sure. The first thing I would say is the fact that this is all happening at the same time for everybody is a good thing. It means that your competitors are looking to try and find something different, and that means it's a perfect opportunistic time to be spending your individual manpower looking at alternatives. In terms of OpenShift and all the benefits it brings, I think the biggest fear that some people have when they start approaching this is, man, we've been using VMware or whatever, maybe it was a different solution. Maybe you're on bare metal, whatever, right? But regardless, we've been doing this for 10, 20, maybe 25 years, whatever. We've been operating inside of these platforms, and we don't just want to uplift everything and move it over. That's okay. Right. Thing number one is we could make it really easy for you. We'll talk about this shortly, but there is a migration toolkit to try and help migrate those workloads over in a very seamless fashion. But you don't need to migrate everything day one. And in fact, I would say it's probably beneficial for you to crawl, walk, run approach this, where maybe we start with just some legacy applications, bringing them over and letting them start to talk to some of the rest of the infrastructure inside of OpenShift. Individually modernize those pieces. Maybe if you're on, say, an old, web application platform like Tomcat or JBoss, that maybe you start migrating over to something more native for Kubernetes like Quarkus, and we can put it into a container. And then we can really start leveraging all these tools that are in there. I think the benefit to you then is because you still have that old landing zone of VMware to live on, at least for a little while, you can build up the skill sets you need to start adopting this. And the benefit does not just stop with, hey, we can run VMs in some other platform from a more cost-effective perspective. Again, you're getting the ability to do two different things. Thing number one is reduce your tool chain for containers and VMs down to the same tool chain, which is going to, greatly consolidate everything you end up using. And the second thing is you're ultimately going to have all of your workloads in the same location. So again, you're going to get this benefit of not having to manage not just two different tool chains, but two different platforms ultimately for doing the exact same type of things that could be commingled. So we really recommend that kind of crawl, walk, run approach. That way you can gain the skill set, but also so you can really start taking advantage of the entire platform without fear of, hey, this feels overwhelming for me.
Gotcha. So it's certainly more of a marathon versus sprint.
Yeah, I would say so.
So tell us a bit about OpenShift virtualization.
Yeah, so I briefly spoke about kind of the constructs here, but again, OpenShift virtualization at the end of the day, it's a add-on function for OpenShift. So OpenShift is based on Kubernetes, and for those who aren't aware, that's a container native hosting platform that essentially is a software-defined data center. So again, software-defined networking, software-defined storage, software-defined service discovery, the whole gamut, right? What ended up happening was because we realized this entire ecosystem was already solving so many challenges for so many different things as it related to containers, the community thought, why not create a new subsystem that leverages virtualization as the primary function and build it into the same constructs? So in terms of the way things normally run inside of OpenShift, we usually take a container or multiple containers if they can run on the same machine, and we glue them together in what we call a pod. That pod ends up having the functionality of monitoring the state and health of a wrong running system and then getting it scheduled onto different machines in the environment. In the case of OpenShift Virt, we stuff a small instance of KVM. For those that are aware of what that is, it's kernel virtualization for Linux. We stuff that into a containerized workload inside of a pod and then run a VM inside of that pod, then thereby giving them access to all the features and functionality that OpenShift natively gives for everything that containers usually have access to. That can then be run on a really lightweight operating system. It can be run on Core OS or Red Hat Enterprise Linux, depending upon what your needs are. But ultimately, this is going to give you the ability to have the same API for, again, both your containers and your workloads. So if someone's used to using OpenShift and they've adopted, Helm for being able to manage their workloads and Kubernetes YAML, they can now apply those same constructs and same CID pipelines over to now virtualization workloads living in the same platform.
Gotcha. And what are some of the gaps in capabilities that folks need to keep in mind as they're making this transition?
Yeah, I wouldn't necessarily call them gaps. A lot of the problems have been solved over time. So when it first came out, there was things like you couldn't have multiple NICs on the same VM. You couldn't have multiple storage providers attached to a VM. All of those things have been resolved and they're all taken care of now. The biggest thing that we try and talk to people is the way that software-defined storage works with OpenShift is a little bit different than a traditional platform, in the sense that the storage platforms that were traditionally built for VMs usually have direct access to fiber channels, which allows you to have very, 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 very low latency in terms of how you're able to access storage from a VM and say it's, inside of VMware. OpenShift wasn't originally designed to talk to that. It was really more designed to have an abstraction layer for how it talks to storage, where you would talk to what's called the CSI driver, and the CSI driver would then interface with whatever underlying storage you have. That hasn't changed, but there have been drastic improvements over time in terms of how OpenShift is able to let virtualization workloads using solutions like Portworx talk directly to fiber storage when it's accessing a VM. And then long term, if someone wants to live migrate a VM from one instance to another, it can temporarily switch that storage to a read-write many block to make that functionality possible in a container native construct. So most of the problems, if not all of the problems that we've seen in the past, or maybe not problems, but maybe things you might be concerned about, I think have pretty much been solved for at this point, as long as you're using the right tool chain and the right tool sets.
Got it. So tell us about some of the companies that have embraced OpenShift, made this transition, really paved the way for the rest of us.
Yeah, so there's quite a few. SiriusXM you have up on the slide right now. They are a very big adopter of OpenShift. For them, The biggest thing that they talk about in their use cases you can see on the screen is the migration toolkit. OpenShift's migration toolkit essentially is a tool that you install inside of your VMware platform. It can also be installed inside of Red Hat Enterprise Virtualization, Red Hat OpenStack, and some other distributions as well, where you essentially have an operator that runs an OpenShift that communicates back to it, and it live migrate copies the VMs over automatically one for one, including their networking settings, their storage settings, etc. I mean, serious, I think the biggest thing that they were worried about was making that migration change, but it's funny, they even say it, and this is a direct quote from them, the migration was the easiest part, because it's literally once you set up the migration toolkit, which takes, maybe an hour to get things installed appropriately, it's a few button clicks to move VMs over from one instance to the other. The only downside to when you're going to do it, it's not really a downside, but just known gotcha is you have to make sure that in order for the migration to finish, you got to turn that virtual machine off completely in VMware so it can finish doing the data synchronization. But beyond that, it's become real streamlined and real easy to the point that customers are raving about how simple it is to make these jumps. So that would be the first use case for sure. The second use case would be the advanced weather system for North America. They've adopted OpenShift virtualization at a massive scale. We're talking 150 plus sites where they're running OpenShift virtualization. Pretty much anytime you're seeing forecast reports come from them, we've been able to have them run in the background. All of the services that support any one of their forecasting systems are currently running inside of OpenShift Virt. That is like a massive leap, because it's not just the number of clusters, but it's the number of sites that are being reported. And I don't believe we have a slide dedicated to this, but the last one that I really like talking about is NVIDIA. For those who are not familiar with NVIDIA GeForce Now, and there's plenty of other case studies, right? But NVIDIA GeForce Now is a gaming hosting provider. What they do is they provide the ability for people for a $20 subscription to sign up to NVIDIA on their website and be able to access a more or less a virtual desktop that lets them play a game of their choosing in 4K over the internet without any lag or latency. I've tried it myself. It's really, really great. There's hosting, millions upon millions of users, and they're billions of dollars into this. It's all hosted on top of Kubernetes virtualization. So it's really amazing what you can do with this platform. It's not just, hey, this is an option, but people are using it at incredible scale up until this point. So I think it goes without saying that ultimately this is a solution that we can really trust in what's been designed, because we're seeing it used by very large companies in very large use cases. I don't think Ross can hear me right now, so I'll just continue with the presentation for now. So in terms of how we modernize, we're looking at 3 different key areas. At least this is the Shadowsoft prescription model for how we do this. Normally, we're going to be setting up an assessment with a company where we look at what are the workloads you're running inside of VMware? How are they being accessed? What type of storage requirements do they have in terms of the volume of read-write requests to anything? Just to make sure that some of these new modern solutions are going to pin up one for one, and there's not going to be any level of scrutiny in terms of performance, right? So we do that first. Then we build out a modernization plan from there that looks like what the first 12 to 18 months of an adoption of OpenShift Virt is going to look like, and how we need to be considering the transition path, whether it be, again, that crawl, walk, run approach, or whether a customer is ready to make a big leap all at once, because maybe they've already adopted OpenShift, but just haven't adopted the virtualization side of OpenShift, right? Then we usually do a technology POC with them where we're either going to deploy OpenShift from scratch or add OpenShift Virt to their OpenShift platform, and work with the customer with the migration toolkit on getting some immediate VMs over and showing them the benefit of how easy it is to navigate inside of this platform and how easy it is for it to use. Long term, then, we're really targeting their more challenging VMs from an accelerated migration perspective. This is things where, like, we're having productionized systems that are specifically using these VMs that can't go down, and maybe we can't even turn them down from a migration perspective. We really work on the process of getting those components over and ultimately setting the customer up for success on OpenShift Virt. With that, I'll turn it over to the last slide. So we've talked about OpenShift Virt a lot. What we haven't done is talked about Shadowsoft in its entirety. I mean, Shadowsoft, we've been around for 15 years. We're a Red Hat system integrator. We've been, like I said, I've been using OpenShift for 12 years, but as a company, we've been using OpenShift since the beginning as well. So every one of our engineers have a long extending experience with OpenShift or massively OpenShift certified. From an administrative and architecture perspective, we have a large standing background with Kubernetes in general, and we help customers adopt these unique, new, challenging solutions strictly for the purposes of getting them to a more modern platform that will help them scale more efficiently. With that, I want to thank everybody for their time today. I want to thank Ross for being here. It's sad that I can't get his audio back, but thank everybody for listening to this time. I hope you enjoyed this presentation. And if you're looking for more information for us, please view us at our YouTube page or go see us at shadowsoft.com.